okay, this is a fourth degree polynomial. I'm getting a general idea what happens to this curve over here. The leading coefficient is positive, so things are going to be shooting up here, shooting up over here. The y-intercept is -2. And I know there's going to be 4 roots to it. Now my question is, where are the roots? Are they complex? Are they real? I do know this, though. I know that there's got to be a connection over here somewhere. So I'm looking at this over here. I know there's a connection there. Now granted, this is not sufficient. I'm going to use the Descartes rule of signs, and to do that, I'll write f of x down for you. And that's x4 minus 4x cubed plus 6x minus 2 plus minus plus minus. One change there, one change there, one change there. So what's s? S is going to be what? That's 3 changes, right? So what could p be? P could be 1, right? Because 3 minus 1 is 2, and that's a non-negative even number, even integer. P could also be 3. All right, so what I want to do is start talking about looking around what happens, get a general idea for it. Now, certainly at some point I know it's taken off. So I'm wondering, is it bouncing back around here between positive and negative numbers? So I want to cut to the chase, and I want to talk about analyzing things. All right? Yeah, I know it's difficult. This is the function. At 0, it's -2, right? So I tend to put a number line down. And at 0, I know it's a negative number. And at 1, it's a positive number. All right, this is done. At 2, it's a negative number. I'm just doing evaluation. At 3, it's a negative number. And at 4, well, this is where things are taken off. It's back down to positives. So what do I know? Something like this, something like this, something like this. So what do I know now? I know there's a root between 0 and 1. I know there's a root between 1 and 2. And I know there's a root between 3 and 4. All right, going back to my original Descartes rule of signs, it said there could be, let's go back over that, there could have been 1 or 3. And now I know there's 3. All right, where are they? One of them is between 0 and 1. The other's between 1 and 2. And the last one was between 3 and 4. Let me highlight where that is. Whoops, didn't mean to do that. 0, 1, 1, 2, 3, 4. We'll look at the picture later. All right, I'm going to erase this. That analysis is done. And I'm going to go to the next set of analysis, looking at the negative roots. Now, by the way, I hope you realize if I found 3 positive roots, there's got to be 1 left over. There's a negative one. So there's really no need to go to Descartes rule of signs. I just need to have to search out where that other root is. And there's got to be one now. There has to be. All right, let's talk about that. Put my little number line down over here. And I'm going to go backwards now. So at 0, what kind of number did you get? You got a negative number. Now let's go to -1. And at -1, you still get a negative number. And then at -2, what do you get? You get a positive number. Well, as we know, the general shape of it, there on out, it's going to be going up forever, right? So now I know there's a root on the interval between -2 and -1. And that's indicated right over here. All right, let's go to the picture. And this is 331. A root between -2 and -1. I got that covered. Between 0 and 1, I got that one covered. Between 1 and 2, that one's covered. And the last one I had between 3 and 4, right? Now, granted, we can refine the shape of the curve, but right now, we're just kind of get a feel for where the roots are, and that's all we're doing, all right? My name is Ron Bannon. I can be reached at this email address if you need to reach out to me. Thank you for listening.